Now we are moving on to experiment number 3, which is familiarization of and implementation of programs related to process and thread. Process and thread are more or less similar, but there is some difference between process and thread. Process means if you are creating a new process from a current process using fork, an exact replica of this process is created. A process is having a data area, code area, stack area, and some other area also is there. So when you are creating a new process using fork, what happens is this creating an exact replica of this. That means everything is replicated. Okay, everything is replicated, and as I told you regarding the life cycle of a process, when using for a child process is created, using that child you can execute some other program. You can execute some other program using exec command, and you can return back to the current process or the parent process. Until that the parent has to wait. Okay, so I'll show you the code for the implementation of that. Here I am having a program which is in the main program we are calling this fork, and this fork returns the process ID of the child in the parent process, and in the child process that will be 0. That means after that you have a child process as well as parent process executing. In the child process that PID will be 0, and the parent process that will be non-zero, and that will be greater than 0. And if PID is equal to 0, that means it is the child process. Then using exec the system call, exec, some variations for different types of exec are there. Anyway, thus exec system call is used to execute a program, and this is you in the inside that this is the program you want to execute, and suppose that there are some command line arguments for that. They are given as argument B. That means here we have arguments set, and if you have a set of arguments here for this child, then once this child process is executed, when this exec system call is called, that child process is completely replaced by this program 2. That means that area is evacuated and that will be replaced by this program 2, and these are the arguments for this program 2. Okay, so that is for the parent child process, and the parent process, for the parent process this won't be executed. That means if PID is 0, this won't be executed for the parent. This is for the child process, and after that what will happen, wait system call is executed by the parent, and it is waiting for the child to complete the process. So when this is executed, what will happen, initially the parent process is starting, and upon executing this fork command there are two processes. The child process is executing, and when that exec the system call for the child is executed, what will happen, then that is completely evacuated and that will be replaced by program 2. Then program 2 starts the execution and it is completed, and once it is completed, until that the parent has to wait, and upon termination of the child process it will continue execution and it will be terminated. That means after this fork there are two processes, parent and child. Child executes the program 2, and once that program 2 is executed, it will come back to the parent process, control will become back, and that will exit. Okay, then what is program 2? Here I am having a simple program which is having program 2.c, and this command line arguments are void main arguments here, cursor argument B. That means you are having two arguments, and ASCII to integer conversion for argument number 1 and ASCII to integer conversion for argument number 2. Argument B of 0 is the program name itself, Argument v of 1 is the text after that program name separated by space, and the second argument is argument v2. So those are text files, and those ASCII values have to be converted to integers, that is a2i of argument v of 1 and a2i of argument v of 2. So after that the sum is calculated and it is printing the sum. Okay, now I am going to execute that. See here, clear. I have that two programs using GCC minus O. GCC minus O means the output will be redirected to this expt, I think it is expt2, experiment number 2. So I am going to save it as expt2, expt2.c. That means the meaning of this is I am going to compile that unless you specify GCC minus O expt2, and if you simply give GCC expt2.c, then the output is redirected to a.out. Here in this case the output would be redirected to expt2. So the executable file will be expt2. Once this is executed, what will happen? Now we are going to check whether expt2 is there. 2 expt2, yes, it's there, that can be executed. Now this program 2.c should also be there in that. That means in this directory program 2 should also be there, which is the executable form of this program 2.c. Program 2.c has to be converted to program 2, which is executable file. So for that, what you have to do is prg2, it is not prg2, it's actually prog2, prog2.c. So that's also executed. So now I am executing this ./expt2 followed by arguments. Suppose that, see, this program 2 is adding two numbers. Those arguments are passed by this XFV system call. That means here we are actually starting the execution of this expt2, and at this point it is creating a new process, and for the child process the PID is 0, and it is calling this program 2. Then when it is calling this program 2, what will happen? That program or that child process completely evacuated, and that will be replaced by program 2, and program 2 starts execution. So for this program 2 you need some arguments. So that arguments I have to pass here. That means suppose that I am giving say 5 and 8. That means expt2 5 8, what will happen? Sum is equal to 13 means here when this process ID equal to 0, what will happen? This program 2.c will be executed, and the two arguments I have passed 5 and 8, those are converted to integers. Then after that sum is found out, and sum is equal to 13. That will be printed, and that is the termination of this program. So that's all about process. We have discussed process in detail. Now we are going to discuss thread. Thread is a basic unit of CPU utilization. It has ID, register, set and a stack. Normally a process has a single thread of control. However, processes can have multiple threads of control which will allow them to perform more than one task at the same time. The main difference between thread and process is having code area, data area and stack area. They are different. That means if you have two processes, then all these data area, stack area and code area are different. But for threads they are sharing the code area, and data area will be different. Okay. Now for creating a thread, you have to initialize a thread using pthread init attr. That is the function used in C, pthread init attr, and in that the attribute set you have to pass. This function sets the attributes of thread like stack size, what is the stack size of the thread, scheduling information, etc. Then pthread create, that means what's that, once that thread is initialized, then for creating thread, this function is used for creating a thread. It takes the following parameters. That means initially you have this thread ID, address of KID, which is the thread ID returned by the on completion of the creation, and these are the attributes you have to pass. And after creating the thread, control will be transferred to this function pointed to by PFNC, and for that function you have a set of arguments. Those are ARG. Okay, then you have a parent, and that parent is creating a thread, and then after that if the thread you have created, it is completing the execution and it will join the main thread. Okay, the parent thread waits till the child terminate and join the parent. Afterwards the parent continues execution. That means upon creation of thread, it is doing some other job, and after completion the parent is waiting for the completion of the child to process or thread to complete the process, and upon completion it is executing the program. Okay, so if you want to do a subtask, then either you can use forking or you can accomplish that through threads. Okay, now I am going to show you the example program. This is expt3.c, and in that process here you have a function. That means, see here in the main program you are reading two arguments, two numbers, and ASCII to integer conversion. That value, you have defined an integer variable, integer array val2, then that is that to having two values, value of 0 and value of 1. Then afterwards we are creating a thread which is called tid, and after creation of the thread it will jump to this function sum. This is the function name, and these are the parameters. Value holds the parameters for the execution of this function sum. So at this point in time you should remember, if you have a thread, then the signature, the method signature should be like this, nothing like that. You can't have int star. Inside that you cannot have int star. Everything should be void star. That means that function sum is returning a void pointer, as well as the input to or the passing parameter should also be a void pointer. So then after that you can override that. That means it's a void pointer, and see, this is function sum and this is value. That means here actually you are passing a value which is an integer array, and once it is passed, what will happen? Once it is passed, here void star argument, that means it is receiving it as a void pointer, and that is pointing to an address. And here see this int star argument means you are converting that void pointer to an integer pointer, and the content of that address value is accessed. After that, here see int star arg plus 1 means int star arguments means actually it's a pointer to an integer value, and that pointer is incremented by 1. That means next value, and again that's an address, and the content of that is run using start int star arg plus 1. Then after that, sum is equal to star this one argument plus this one means sum is equal to this plus this means those two numbers are added. As this sum is a global variable, this sum is holding the added value. Okay, see here, using pthread create, we have created a new thread, and after that using that thread you are calling this function sum, and you have passed this value as parameter to that function, and you have converted or you have found out the sum. And after that, here this pthread join TID means you have the TID created and the parent process is waiting for the completion of the thread, and so once it is completed, it is printing the value sum. Okay, I will show you how this can be executed. When you are compiling a program which is having a thread call, you should have something like this minus LP thread, gcc minus o xpt3 xpt3.c minus LP thread means you have to compile xpt3.c and the output file is expt3, and here in this case you are going to use pthread create, pthread join, etc. In that you have to use this minus LP thread also. Once it is there, it is successfully compiled, and now you can have this expt3, and now I'm going to pass 6 and 9 as the parameters. Then inside that thread you have read 6 and 9 and the sum is 15. Okay, this is the way we are going to execute a thread. That's all.